When you're working with tables in a database, it is important to know up front that the way the data is stored differs from the way we query it for reporting. In this lesson, we will dive into the way databases are designed in theory. We will discover the way we use tables, the process of normalization, and we will also have a brief discussion about denormalization.
Hey there! If we haven't met yet, I'm Lieutenant Commander Data, your favorite data nerd and the galaxy's favorite teacher in anything involving data. I'm the host of the LC Data channel, and I will break down some data concepts and show you tips and tricks behind the most popular data analysis and reporting tools. In my world, and yours, I've been a certified trainer in various data platforms and disciplines for the past 2.5 decades, and I train thousands of Earthlings working in many different industries, humans just like you. Oh, and all of the websites and resources I mentioned in my videos are linked in the description box below. I also posted how and where you can download all the project files I use in my demonstrations. If you are a big fan of data in general, then we have something in common. So go and smash that subscribe button and hit the notifications bell so that Scotty can notify you every time I have an important transmission to share with you.
Now, buckle up and get ready to lift off, Earthlings. 5, 4, 3, 2, 1. When a database is designed, the data is structured for optimal storage and use within the program. That means the data is normalized. Normalizing data is a way of organizing your data, and it supports the design by optimizing storage. Normalization of data also adds flexibility in working with the data to support the design of front-end interfaces. As a data analyst, you hope to work with databases that have followed proper design theory. Proper design theory is accomplished through a series of sequential design rules and the principles of the normal forms. Most database designers will at least attempt to get the data to the third normal form. But what do I mean by that? Let me explain. A normal form is a step or phase in the design process that enforces specific design rules. The first normal form eliminates redundant information in individual tables. Each set of related data will be stored in a dedicated table. Each table of related information will have a primary key assigned. In the second normal form, related information that is applicable to multiple tables will have its own table and will be associated using a foreign key. The third normal form eliminates fields that do not depend on a primary key field. You will likely find that while some designs go to the third normal form, most do not. The less practical fourth and fifth normal forms are rarely used, so we won't go into them here, but you should know they exist. Now, let's see how the normal forms are applied with a few examples. Here, we see a table with employee data. The table has a column for 3 dependents for each employee. There are 2 problems with this design. Firstly, if an employee has more than 4 dependents, we are stuck. To capture 4 or more dependents, you will have to store the employee more than once. That means that the main entity, the employee in this case, will be a duplicate with 2 distinct primary keys, and we are using unnecessary space in storage because we must capture the employee's personal information twice. Secondly, an employee may never have any dependents at all, but because fields are defined for up to 3 dependents, you are also wasting space in storage because some space will be reserved in the data files for dependent information, even if they don't exist.
If there are only supposed to be 114 people on board, why all the extra space?
Transportation of colonists, diplomatic missions, emergency evacuation.
Thank you, Mr. Davis.
To resolve this problem, the designer will apply first normal form. It dictates that redundant or repeating fields must be eliminated in tables. Those repeating fields will then be placed in a dedicated table with its own primary key. A foreign key will also be added to the new table that will match the dependents to the corresponding primary key of an employee. That is how we then identify the dependents that relate to a particular employee through a relationship. The designer must first complete first normal form before moving on to second normal form. Second normal form dictates that related information that is applicable to multiple tables will have its own table and will be associated using a foreign key. Let's look at our example again. Here we have the employee table again. An employee works in a department. The department code and department name will be stored in the same table that stores the employee data if we use the current design. But there is a problem with this design. This employee is not the only person working for that specific department. So, if we have, for example, 10 employees working in the IT department, it means that the information for the IT department will be stored 10 times, and that will use unnecessary space in storage. To resolve this problem, the designer will apply second normal form. Again, second normal form dictates that related information must be placed in a dedicated table with its own primary key. A foreign key will now be added to the employee table that matches the primary key of the departments they work for, and that is how we then identify the employees that relate to a particular department through a relationship. The designer must first complete second normal form before moving on to third normal form. As I mentioned earlier, you will likely find that while only some designs go to the third normal form, most do not. That is because many times third normal form is already in place after applying the first two normal forms. Let's look at our example again. Here, the employee's primary key is employee ID. An employee record depends on the employee ID for identification. That means all the current fields that describe an employee must be in this table. In other words, the fields first name and last name describe the employee, so they depend on the primary key, but the job title and job description fields are not attributes of an employee. They describe a job. The problem with this design is that this is not the only guy that performs that job. So, for every guy that is a programmer, we will store the same job title and job description, and that is a waste of valuable space in storage. To resolve this problem, we must place job title and job description in a dedicated table with its own primary key. Another foreign key will be added to the employee's table that matches the primary key of the job they perform, and that is how we then identify the employees that relate to a particular job through a relationship. Notice that we have 2 foreign keys in the employees table and only 1 in the dependents table. There is a reason why we didn't put all 3 foreign keys in one table, but we will explore that in the next video. Data that is not properly designed using normalization would be referred to as denormalized data. When data is not structured into tables using normalization, you will find lots of redundant and repetitive data. Consider this example. For every dependent of an employee, the employee information, such as first name and last name, is entered into the table. This is an example of denormalized data because the employee information is manually keyed in and repeated each time a dependent is added. It is important to understand that there are other reasons for denormalized data to exist that are not related to design flaws in the data entry process. Data analysts actually denormalize data for the purposes of analysis quite regularly through querying. Highly normalized databases are good for data that is inserted, updated, and deleted regularly, but it makes querying your data slow. The process of querying involves gathering data from all the different single-source tables and joining that information together for the purposes of data warehousing, data mining, analysis, and visualization. The end result in the data set appears denormalized. This is also called flattening the table. Normalizing data breaks it down into multiple tables, often up to the third normal form, and the end result is a relational model. But denormalization brings it back together in lesser tables. When doing denormalization for a data warehouse, you transform the relational model into a dimensional model with flattened tables called dimensions. Let's revisit our employees' data example. If we were asked to produce a list of meaningful data that shows each employee and all the departments they worked for, we'd see a lot of repetitive data. We don't want to store the data that way for obvious reasons, but for reporting and analysis purposes, we need that redundancy so we can create appropriate reports with all the necessary information. It also makes searching data more efficient because queries do not need to traverse across parent and child tables using relationships. So, normalized data makes inserting, updating, and deleting records more efficient, while denormalized data makes searching and reporting easier. As you go through these lessons and begin to understand how we join data together, you will be performing denormalization. Okay, Earthling, that's enough for now. I will leave you now to process the information I shared with you today in your own time. Remember to subscribe and, while you're there, give me a thumbs up. Thank you for watching. I'll see you soon with another insightful transmission. From me, Lieutenant Commander Data, live long and prosper, Earthling.
Say goodbye, Data.
Goodbye, Data.